Good morning. I'm Tim Perry. I'm going to be talking about real-world microservices here. We're going to take a look at the content pipeline that powers a major news application we built recently for the BBC. Look at how the actual architecture of that comes together. Look at some of the ideas and different options that were available, and the benefits and downsides of this you actually see in practice when building services like this with microservices. Some context to start with. I work for a company called Softwire. Has anybody ever heard of Softwire? Ah, nice. Okay, cool. 4 or 5 people there. So we have offices in London and Bristol and here in Bucharest, and we are hiring here in Bucharest. If you want to do any really interesting software development, if you want to build amazing stuff and you're really good at it, we'd quite like to hire you. So do come talk to me later about any of that kind of stuff if you're interested, and we're also available for hire. We do bespoke software development for other companies. We make products for other people, like the BBC, like what we're going to look at today, and we are desperately looking for really good people. What I'm actually talking about today is Newsbeat. Has anybody ever heard of Newsbeat? 1, 2, 2 hands. So Newsbeat is BBC News for a slightly younger audience. So they're trying to be slightly more accessible than main BBC News and appeal to about 16 to 24-year-olds as part of the BBC's wider platform. We're really trying to focus on this audience, which gives you slightly different constraints to what happens if you're building BBC News, for example. We care more about polish, about things feeling very slick and swish, because that's what this audience cares about. We're also very much focused on speed. Our real competitors here are people like Twitter and Facebook. That's where this audience gets their news from. And BuzzFeed, this kind of thing. All of whom focus on getting information out really, really fast. We have to give people accessible news very, very quickly, but with the same things that the BBC prides itself on, being trustworthy, being neutral, being very informative. This is a rewrite of an existing application, modernising it and bringing it into the modern age. So we're moving from a relatively static website to a responsive site that's going to work on tablet and mobile as well, and Android and iOS apps. I'm not really going to look at the front end very much here at all. What I want to look at today instead is the back-end systems we have in place that takes content from journalists and puts it into people's hands as quickly as possible. This is part of a modernising approach within the BBC generally, and as part of this we're trying to update the technology too. They're moving from running things on their own servers that they manage towards AWS. They're moving away from Java and PHP towards Ruby, and this is one of the big projects trying to shift an existing site along that kind of direction. If you want to actually take a look at this yourself, you can. It's up at bbc.co.uk/newsbeat, and there's Newsbeat apps available. I'm going to walk through the UI a little bit now so you can see what exactly we're trying to produce, but you can take a look for this too, as you like. The main site on desktop looks something like this. It's a series of stories. It tells you the news in card format. Each of these has various tags for specific topics they're talking about in the corners here. And we've got various different pages for this. We provide the latest story here, some of which is very new news, some of which is editorially selected and highlighted. We've also got the most popular stories and topics on separate tabs that you can look at and see information categorized in various different ways. Each of these articles looks something like this, and there's the full body down the side here. So we've got some body content, and then we've got various extra little components, like this most popular sidebar. We're building this on top of some slightly legacy infrastructure within the BBC. The actual systems that journalists write news into are used by all journalists in the BBC. They power things like BBC News, and they're very difficult to change, certainly out of scope of this project. So we have to keep integrating with these to get all our data. These are quite expensive, and because we're moving to AWS, they're no longer co-located with us. So we have to make quite slow HTTP requests for each bit of information we want. Building a page like this becomes quite expensive in that environment. To make this page, we go and hit the content service, and we ask for the text of the body here. We then have to go and hit the tagging service, which relates things and get the actual tags for the content. Then for this most popular sidebar down the side, we have to go to a most popular service, which gives us the IDs of the articles that are popular, and then for each ID we have to go and subsequently make a request to get the information for that article, and then another request to get the tagging data for that article. And then we've also got a related stories, smaller sidebar in the middle here, and then down towards the bottom we've got the latest stories, so another selection here which requires another request to another service, and then sequentially after that a series of requests for the data for each of these, and more tags for the articles, and so on. Rendering these pages takes quite a bit of time. It's quite a painful thing to do. It's also somewhat fragile. We're building on this legacy structure that is going to potentially, occasionally, fail. It is not built to handle the scales at which it is now running, and it has been difficult to maintain for quite some time. We've also got responsive versions for tablet and mobile, and then actual apps. The apps are showing essentially the same content, but rather than being given HTML of an entire page, they request the individual bits of JSON they need and then compose that on the device. These are native apps. The key thing I want to really hit home here with is that these pages are expensive to build. We have to do them in a whole series of different formats, different structures. We have to go to a range of different painful back-end services to actually get this information, and generally this is not a CRUD application anymore. We can't just hit a database, join all our data together and pull it back out. We have to very slowly and carefully piece it together from different sources. Hopefully this doesn't sound too bad still. We're in relatively understandable space here. This isn't anything particularly crazy. It's a largely static site. It gets more difficult. We are going to launch this initially to quite heavy and very spiky traffic. We were aiming to be able to support about 2 million daily users on this site from day one when we launched, which for comparison is about the same as Slack. That's quite a lot of people. This is more complicated. This gets worse because it's a news site, which means traffic is incredibly spiky. If you publish a major story, you'll get those 2 million users in half an hour, in 10 minutes. Kanye West will occasionally tweet links to us, and that will be very painful, very suddenly. Traffic here becomes incredibly spiky, and this is something that you particularly get in news organizations like this, and it's generally a hard problem. Still, we can manage this. Caching generally is going to be a nice way of doing this. We scale out our caches, the content doesn't change that much, and it's fine. Unfortunately, we also need to get our content out really quickly. We're competing, as I was saying, with Twitter and Facebook and BuzzFeed, who compete on the fact that they get information out that this audience wants to hear fast. We want them to be getting their news from us. We want to be getting the news into people's hands quicker. On top of that, the way that the BBC and major journalistic organisations publish news means that we have to be able to push updates quickly. Typically, if you're writing a breaking news story, you will write the first intro snippet and immediately publish it, and then as you get more information, as you find relevant images to include, you'll continually update it and republish as more and more of the story comes together. Thus, we have to be able to get updates out quickly. Even more important is redactions here. If at any point the BBC publish anything wrong, we have to be able to take it down and correct it on any article we've ever published. All of this means that we need to be able to update any piece of content anywhere to users' devices within about a minute as a maximum, preferably less. This means caching everything enormously is quite a bit harder. We've got thousands of these articles. On launching, we published not just with the new Newsbeat articles, but republishing every article they have ever written. And managing this gets harder. We're also building on top of these back-end services, and they require some care. If we hammer these with traffic, particularly, we can break them. And if we break them, BBC News potentially breaks, and that is international news in itself. That's very embarrassing, and I certainly don't want that to be my fault. We have to ensure that whatever we do, we don't release anything that could potentially flood these back-end services with traffic. Not only is it a big risk for us, the BBC simply won't let us do that. They're going to audit our approach, they're going to require reviews on things we release, and ensure that we cannot release anything that will take everything the BBC does offline. So we have to be very careful with these, and we have to be prepared to deal with the problems that are going to be created in these. They're going to be slow to respond, sometimes they're going to fail. We have to manage all of that and remain very reliable. A big part of what the BBC does is being the public face of big, serious, very well done, very reliable journalism, and having stuff break all the time really messes with that. We want to ensure that even when these backend services go down, we keep serving the best news we have available. If our internal components start breaking, we keep serving the news for as long as we possibly can. I think this now sounds a bit more difficult. There's some challenges in here, there's some tricky bits. What I want to do now is look through some different architectural approaches. We're going to start with a very simple way that we could build this. We're going to see why that's a terrible idea, and then progressively evolve it and look at the problems we have at each level until we get to the actual Newsbeat architecture. This is hypothetical. We didn't actually build this badly and then evolve it over a long time. We went through discussions, came up with most of this architecture right at the beginning, and then built it from there. But I'm hoping this is going to illustrate nicely the kind of different considerations you have to think about when you're building this kind of stuff. I should note this is not just Softwire's idea. The BBC have been playing with a lot of the ideas and concepts behind this for quite some time. This is the first time they've taken these and we've taken these into running a full major news site like this, but the BBC deserve a lot of credit for the work they've been doing trying to evolve their systems in this kind of direction for a while. To start with, we'll go for really the simplest approach. A request comes in from the website or apps. We go and we get all the data we need for it. We stick together some HTML or some JSON or whatever, and then we serve it back to them. I suspect most people in this room have probably built a service, something like this at some point. It's very easy to do, it's very simple, it is absolutely not going to work for this case. There's a lot of reasons for that. The biggest one is that as soon as Kanye West tweets about us, we are going to suddenly flood the backend services with 30, 40 slow, painful requests for every single page that his followers click on. And as soon as we do that, the backend services are going to go down, and we are going to get sued, and the BBC are going to be very, very unhappy. So, how can we take this and turn it into something that can handle millions of users suddenly turning up? How can we transform this architecture to do that better? The very first thing we can do is stick a cache in front of it. It's just a fairly easy, obvious solution. We use Varnish for most of our caching. It's very, very good. With this, we can very easily set up, say, a nice time-based cache and cache every bit of content we have for, let's say, 30 seconds. When requests come through, every 30 seconds, one of them will actually go and load all the data and re-render the article. But all the others will just get our previously cached data. Everything becomes much cheaper, and we drastically reduce the amount of damage we do. This still isn't going to work. The most interesting reason why is what happens on cache misses. Whenever a request comes through this cache because content has been evicted or because it's come before we've successfully cached anything, so when we first publish articles, those requests end up rendering synchronously. They end up waiting for data loading. And this is a big problem because data loading is very slow and because data loading can fail. If we have requests that are synchronously waiting for us to go and get content from the BBC, then if that ever fails, they are going to see errors. Even if that doesn't, it's going to be very slow, and we're building this site for users who care about speed, who care about being able to quickly flick through the news. This is a larger problem than you'd imagine, particularly on news sites, because when you publish a new article, immediately a lot of people click on it. You have to be able to ensure that when that first wave comes through, it's ready, it's fast, and we're not ever, preferably, synchronously blocking on these backend services. So, how do we take this and ensure that no requests that ever come in are actually waiting for our content services? The first change we can make is actually just loading our data asynchronously. If instead we have a separate service, and you start to see the microservices coming out here, a separate service that just goes to the BBC and grabs the bits of raw data that we need and then stores them in a very cheap local store that's available to us. All of a sudden, we never have requests waiting for this. This backend service, every some time period, let's say every 30 seconds, goes through loads of data, updates some database. Let's not worry about what it is too much right now. And later, when requests come in, they eventually come through a cache, and we say, we want to render this article. So we just go to our very, very cheap, very local, reliable database, and very quickly, and very easily, and very safely put together the content we need to build this page. And then we serve that content straight back out. Just like this, any requests that come in now never depend on the content services. We never have to worry about the slowdown and the unreliability that might come in there. We now do have to worry perhaps about this data store, but it's much easier to make that safe, to easily find data stores on AWS, certainly, that will scale up and handle this kind of thing. This still isn't going to work, and one of the main reasons is something I've glossed over here, which is what exactly this timer has to do. To get this data in, we have to reload the data for every single article. If we want to get any update to any article within a minute, that timer needs to be triggering an update for the data for every article at least once a minute. If we do that, that means we're requesting all the data for all the articles at least once a minute, which is a lot more requests than we want to be making to the backend service. We've got many thousands of articles. This is going to cause problems. Alternatively, if we make this slower, if we update our content once an hour, once a day, even if we start tweaking it around for more popular and less popular articles, newer, older articles, we end up in situations where updates and news don't necessarily get into people's hands, and people can still see out of date and potentially totally incorrect news on the BBC site. This isn't okay, so we want to ensure that this system doesn't go and update its backend data more frequently than it needs to. What we'd like to do is, preferably, only get new content from the content services when the content has actually changed. We only want to go and query them when we know that we're actually going to need to. Fortunately, we can do that because the BBC Content Services will give us notifications when it publishes new content. And with a bit of fiddling, we can plug these into SQS, Amazon's simple queuing service. Every time we get a notification from the content services saying article 17 has been updated, we put that on a queue, and now all the load data microservice has to do is listen to a queue, and when it finds a bit of content on there saying this article has been updated, go and get the data for that article and throw it in our data store. Notably, the front end doesn't change here at all, and actually doesn't even know that this change has happened. This is where you start to see the maintainability benefits in practice of microservices. Had we actually released the first version and then wanted to change it to this, we could have done that at runtime, entirely decoupled from what's happening at the front end. This is still not going to work. Probably the most annoying thing here is that we still depend on constantly re-rendering the content that is in our data store at the front end. So we've moved all the raw data into a local store instead of this expensive distant set of services, but we still have to, whenever something comes through the cache, whenever requests come through here and hit that render and serve service, we still have to go and for the 30 or 40 different bits of data we need, pull them from this database, glue together this whole page and serve it back out, even though nothing's changed. And it feels like we can take the same information the same trick we've just done for data loading, and do that for rendering as well, and avoid constantly re-rendering data. Anything we can do to avoid re-rendering data is good. The BBC, as you might be aware right now, is having something of a budget crisis and would like to reduce its costs wherever we can. If we can avoid our services doing too much work and make them cheaper to run, that's very valuable. So, how do we do that here? We push rendering back into the other service again. And now, when we get a notification saying article 17 has been updated, we don't just go and get the new data for that article, we also build the entire HTML page, and then we throw that page into S3. All the front end now has to do, when you ask to load an article, is get the totally pre-rendered page, pick it up, and serve it back. It does basically nothing. This is really nice as an approach. The front end here does, yes, absolutely nothing. Critically, that means it's very fast and it doesn't break. Even if this backend service completely fails, and all the content services fail, the front end just serves the latest news out from S3, whatever it had before those services failed, and can just keep going indefinitely. When you build small services like this that don't do anything, they don't break. Small, simple services really make these kind of requirements easier to hit. This has actually created a new problem for us, though. In this, we have to render whole pages and throw them into S3, and different parts of pages change at different times, and we end up re-rendering the common parts. If you think back to that article page, down the side we have most popular content. If we get an update for an article, we have to go and reload all the data for our most popular content for every article as it changes, even though that content might not have changed. Even worse, if the most popular content changes, we have to re-render every single article. That is very expensive, it's going to break, we don't want to do that. So we want to take this and ensure that when we get changes in different parts of the page, we instead cache only that part of the page. This bit's a little trickier, but what we do here now is start actually breaking these into more services and moving the composition of this data together onto the front end. So now an article gets updated. The article renderer, and only the article renderer, gets informed about this update. It renders the HTML for part of the page rather than the whole page, and throws that chunk of page into S3. We've got a most popular renderer that also gets triggered, actually by things thrown on a queue by a timer, but it doesn't know or care. That gets triggered and renders the most popular sidebar and the popular page, and throws those into S3. Then on the front end, when requests come in, they go to S3 and they compose together 3 or 4 bits of page. They grab the body for the article they're looking for, and the current most popular sidebar and the current footer, and they stick it into a page and serve it out. We've moved a little bit of work back onto the request pipeline, but by doing so, we've reduced the requests we make through to the content services down enormously. We now make requests through to the backend really only when something has changed, and only for the thing that has changed. Nothing else. We can still make one small last change to really finish this off though. Critically, the front end part of this is still a bit more complicated than it needs to be, and the apps aren't really using half of what it's doing. They come in and ask for JSON, and the JSON is just the individual components. So they're not doing any composition at all. It would be nice if we could decouple these, if we could break these out, so that if the composition stage starts exploding and failing, the apps just keep working, they don't have to care. And we can do that quite easily. We take this and we split that front-end service in half. Now we've got some even dumber, simpler, harder to break services. This broker here takes a request for a piece of content, let's say an article with ID 21, and I'd like the HTML format. And it knows how to look it up in S3 and serve it back. That is all it does, absolutely nothing else. It is a lookup service for S3. The composer, meanwhile, knows how to glue this together into whole pages. This is what the website needs, but not what the apps need. And now these individual parts can fail and indeed be scaled totally separately. This is more or less the actual architecture for Newsbeat. This is the actual structure that we're running in production. It works very well and gives us most of these benefits we were talking about. I want to dig into these components a little bit to make sure that they're clear and this pattern works well. This is a pattern we're using, but is also not that dissimilar to patterns in many other places. Twitter is another interesting example where this same kind of thing works. When you load Twitter, they do not go and check through the tweets for each of the people you follow and then put together a timeline and show it to you. Instead, they too are doing the same kind of pre-rendering here. when you tweet, it goes and renders the timeline for everybody who follows you and updates the tweets into there. So that when you're actually loading the site, when you're actually browsing it and reading the tweets, which is what's happening most of the time, that is very, very quick. Everything you do asynchronously, you pre-render and do it in advance. This works with these back-end renderers here. The key in doing this is making these very, very stupid and as independent as possible. They don't really communicate with anything. They certainly don't know anything about the front end. All they do is listen to a queue, and when they get a notification on the queue, render whichever bit of content that notification refers to, and then throw the result in S3. This makes them very, very flexible. We needed to, when we first released this site, re-render all the historical Newsbeat stories. To do that, all we did is put the site up and then throw in the article renderer queue, one by one, the ID of every story that's ever been published. From the article renderer's point of view, it's as if they were all just published, just now. And just like that, it re-renders everything. Having these very simple dumb components makes it very easy in practice to poke in and change things. You get lots of interesting flexibility. We did look for a while at having renderers that output into queues, that output into other renderers, that output into S3. And you can build chains here where content is pushed down by this notification queuing system. We've also got the broker. Again, critically, very, very dumb. Doesn't know anything about anything else. Very simple, very stupid. Now, this would actually be quite a good candidate for something to move into AWS's Lambda service. At the time, that was still quite immature. But it's essentially a very simple function. You come in, you request something, it loads data and sends it back. That's it. And then the composer built on top of this. This internally has its own set of templates for what each page should look like. So it's got a small HTML template describing an article page that says you need the body here and the sidebar here and the footer here. And when a request comes in for an article, it works out the ID of the article, looks at the template to work out what it needs, makes the request to the broker. Here, very easy, all in parallel, co-located and very cheap. Makes a request to the broker, just glues the HTML back together and serves it back up. It doesn't have to think about JSON or think about any of the stuff that the apps care about. It is just thinking about what a page looks like and how to stick that together. Again, very simple, very few moving parts to break or go slowly. So that's the overall structure. Each individual part becomes very easy to understand with this. And that was one of the real benefits that we've really got out of microservices. These are individually very easy to maintain, to test, to think about. And content gets pushed through this pipeline. We never end up in a situation where a request is waiting on a series of other services to pull data through, which is the kind of thing you really worry about if you're building microservices, these chains of HTTP requests. Instead, our front end does very little and everything is asynchronous. We push data through up these pipelines from the back end rather than having requests dictating when work gets done. Microservices really enable this and really allow this architecture. In a large monolith, it would be difficult to do this cleanly, to avoid having this become an enormous mess of interactions and mud. Breaking these out into separate services makes it very, very clear that the renderer is very stupid. There's no uncertainty. You don't have to think about how the different parts relate to each other. It's a standalone service. You can read the whole thing in 10 minutes. Under the hood, this is all Ruby because that's the way the BBC are going. This is running on EC2 and auto-scaling, which works very easily for this kind of thing. The renderers just scale on the size of the queues they're waiting on particularly. If more articles get published, we just spawn up more renderers. And the front end, we scale on CPU load. But again, very easy to manage. We use S3 for the actual content storage and Dynamo to handle some consistency things over the top of that with updates. SQS for queuing and SNS, the simple notification system from Amazon to manage the actual notifications that come out. We've got a little bit of very short-lived Elasticache between each of these services, just to act as a common cache for data which keeps getting requested. If you've got a popular article that is currently updating, for example, the most popular renderer and the article renderer will keep updating, keep reading in bits of data for that. So we cache that for very short times just to avoid very quickly repeated requests. and CloudWatch for monitoring, which again with this, because all the interactions are using very simple standard components, works really well. If you want to monitor your renderers, you tick the box in Amazon that says monitor the size of the queue. And just like that, you've got a pretty good idea whether your renderer is working. If the queue starts building up, the renderer has probably crashed. Something has broken, there is some content in there that it is failing to render. As long as the queue is empty, it certainly thinks it is successfully rendering stuff. And similarly, you can look at the amount of traffic coming in and out of the various front-end components. And we actually build more monitoring on top of this, but using these very simple components makes it easy to get started using this kind of stuff on top. It's actually built on some foundations that the BBC have built out. We've been contributing back to along the way. This is now public and available if you want to try it out, if you're building microservices in Ruby. Elephant, it gives you a basic framework for renderers and composers and brokers so that you can put together these same kinds of patterns yourself. It's very good, it's a nice structure, works well. So, that's what we've built. Does it work? Critically, yes. We've released it, the BBC are very happy, it handles Kanye West, everything is pretty good. Performance particularly works really, really nicely here because we just don't do anything, and it's very hard to do that slowly. Requests come in and very, very little happens. That means it just doesn't ever have to wait for anything. There's very, very little work going on here. It is easy if you naively put together microservices by just spreading out your code and sticking HTTP requests through them. It is easy for it to get slow, for you to start to feel pain there. But moving to this asynchronous approach, pushing stuff through, makes all of that much, much cheaper, and it's worked really well for us. It's very robust, like very small things that don't do anything, don't break. Similarly, all the individual components, because they don't do very much, because they don't have many external interactions, are very easy to scale. If something starts breaking on one machine, we can spin up another machine and start running it on that instead, and they don't have any state that we have to worry about for this kind of stuff. Even if they do break, a lot of things keep working. In development, before we had monitoring in place, the renderers would sometimes break, things would crash, and we wouldn't notice for ages because the site keeps going, the apps keep working. It's really, really easy to not actually notice at all that lots of your major components are totally broken, which, while a bit scary, is quite a nice place to be with a production system. Even if things like the composer goes down, the site just keeps working. Some of the caching in place also means that even if various bits of data go down for a little while, stuff keeps going. It is really, really hard to actually take this offline, which is great. Everything internally is very nicely encapsulated and decoupled. This is one of the classic microservice promises that actually really did play out for us very, very nicely. It's very easy to make changes to these. It's also very easy to test them. Understanding what a renderer does is nice and simple. We've got some bits of unit testing in place, but we've also just got integration tests that spawn up a renderer, a fake SQS and S3, and a fake content services, throw something into SQS, and just assert on the content we get in S3. And that is the entire service. You can write a single test that just does that. This kind of decoupling allows you to get in at those gaps and really easily make those kind of assertions with confidence that you're not going to get weird side effects, weird interactions between different bits of your code, because they're actually running separately. The broker never talks to the renderers. It doesn't even know the renderers exist. There's some bits of static content we serve to the apps, various bits of configuration in JSON, which actually aren't rendered by renderers at all. We wrote them and we manually put them in S3. The broker doesn't know that. It happily serves them up like any other content. You can get in at the gaps here. It's powerful. Finally, the actual behavior we were looking for, those tricky requirements at the beginning, are built into the architecture. You could build systems to do this yourself. You could have a large monolith and carefully think about asynchronously handing off tasks to other parts and carefully think about internal caching. You could set up caches up front and do a lot of quite complicated varnish configuration to get most of this behavior. Once you do that though, you have to maintain a quite complicated implementation, and it's quite easy to go wrong along the way. This architecture makes it quite hard to go wrong. It would be very difficult to write a renderer that slowed down the front end. Indeed, it would be impossible, I think. It's very difficult to build systems like this that are going to break. It's not perfect, you can do it, but it pushes you constantly in a direction of doing what your requirements want. If you can make your architecture line up like this, you can solve a lot of your problems right from the beginning, more or less. To wrap up then, this isn't all wonderful shininess. There are problems with microservices even in architectures like this. Critically, everything has to be cacheable. On those article pages we have little bits of content that say things like published 10 minutes ago. You cannot cache that. That will not get updated until the article next changes and we pre-render this HTML. You can't have stuff like that you're not going to be able to notify changes for. So what we actually do here is render those client-side. So we serve up specific times and then JavaScript them out, and then on the apps we render the times natively on device. But you have to be aware of this, and it would be quite easy to accidentally have content that is not cacheable within your content and then just gets stuck and stays forever. Even worse is if your content changes. If you want to change what the body of an article looks like here, you have to re-render every single article you've ever rendered. You can't just change the render article method in the front end and instantly have it switch as you're used to in a web service. Instead, you're going to have to go through and re-render everything because everything is cached. For HTML, that's a bit tricky. For JSON, that's quite a bit worse. You're going to have actual schema changes and you're going to have to think about migrations between them. For us, this wasn't a particular problem. We simply didn't make very many changes. In the longer term, you can see how this kind of stuff can come and bite you if you're really not expecting it. And finally, one of the other key problems here is shared code between these microservices. This is a contentious topic, and there's a lot of people who say you should never, ever share code. You should simply duplicate it. Many other people would say pull it out into separate services. In our case, we've actually got shared code in some Ruby gems as shared dependencies between bits and pieces. This feels to us like the best compromise between these, but it's not perfect, and there's still some pain. Things like rendering cards, so that standard structure of headline, picture, little tag and stuff, that little bit of HTML rendering is shared between a lot of renderers. A lot of the renderers also share small libraries that describe how to talk to different back-end services. Finding nice ways of sharing that code in this structure is not that easy. We could have a separate service that you talk to learn how to talk to the other service, but once you start doing that for all of these, you get a lot of complexity. Gems are not bad, but they're not great. I don't really have a perfect answer for this. Perhaps monorepos and this kind of thing. Perhaps really just more services, but they do come with a cost and they're not free. That's everything I've got for you today. Hopefully this gives you a bit more of an idea of what this stuff actually looks like when you build it, how this actually works once you put it into practice. For us, it has certainly been a good thing. It is definitely a better approach that has really solved the problems we were trying to solve here, but it's not perfect and there are challenges you have to watch out for along the way. Again, I am Tim Perry, Pim Terry on Twitter, and I'll stick the slides out in just a minute, and I do work for Software, and we are hiring right here in Bucharest. Thank you very much.